All right, let's talk for a minute about some of the processes that are going on as a solution forms. And first of all, why would it form anyway? What's happening here? Let's imagine that we have a crystal of salt. And of course, salt is a cubic crystal. So we're going to have little small cations and great big anions, and little small cations and great big anions, so that we wind up with sort of a checkerboard effect between the cations and the anions. Water molecules, on the other hand, look like Mickey Mouse heads, and we have a partially negative end down at Mickey's chin and a partially positive end up at Mickey's ears, where those hydrogen atoms are. Well, that means that Mickey's ears are going to be attracted to the anions. Not just one water molecule is going to be attracted to it, but every water molecule in the neighborhood is going to be attracted to those anions. And pretty soon, the attraction between the anion and these water molecules is greater than the attraction between the anion and the cations. And so that anion is going to float away surrounded by water molecules, all turned with their partly positive ears towards that negative ion. These water molecules that are surrounding it are called a hydration shell, and they will make it hard for this ion to try to go back home and snuggle up to these cations. Can't get to them because all these water molecules are now surrounding it. They're in the way. They won't let it go back home. Down here where we have a cation, well, the water molecules, partially negative ends, are going to be attracted to those. So these water molecules are all going to have their chin turned towards the cation. And eventually, with enough water molecules, the attraction between this cation and the water molecules will be greater than the attraction between the cation and these anions. And so it will float away, surrounded by its own hydration shell. And these water molecules in the hydration shell will prevent it from being able to get back home and rejoin the crystal. And so that's how solution of an ionic compound works, because the water molecules just literally tear it apart. They pull it away apart, one ion at a time. And of course that exposes more ions to more water, and the process just continues. Well, that's kind of interesting, don't you think? All right, how fast does this happen? The speed of the formation of a solution, the rate, is going to be determined by three things. First thing is agitation, stirring. That makes sense because once a water molecule is involved in a hydration shell, it's hard for it to get out of that hydration shell and go after a different ion. It's fully involved. And so if we stir it or shake it or agitate it in any way, that brings the water molecules that have not yet encountered this solute crystal, brings them down here where they are in contact with it, and so they can start pulling off more and more and more of the ions. So bringing in a supply of fresh solvent is a good thing, and you do that by stirring it up. Of course, stirring it makes it dissolve faster. You know that. All right, another thing that makes a difference is temperature. Again, this makes perfect sense because the higher the temperature, the more the water molecules are moving around. And the more they're moving around, the more likely they are to bump into this crystal and grab hold of an ion. So that makes perfect sense. The third thing may not be quite as obvious, and that's state of subdivision. State of subdivision just means how big are the solute crystals. The smaller they are, the faster they'll dissolve. The bigger they are, the slower they'll dissolve. This also makes perfect sense. Let's say that we have a crystal this size. Well, the water molecules can only get to it. Now we're thinking two-dimensionally here about something that really is three-dimensional, but that's okay, go with it. The water molecules can only get to the crystal along 2, 4, 6, 8 squares of area. And of course, if the water molecules can't touch the crystal, they can't dissolve the ions. They can't get hold of them and pull them away from the crystal. If we put this in our mortar and smash it up into pieces with our pestle and break this crystal into smaller pieces, now the water can get to the crystal along 4, 8, 12, 16 squares. Oh, it's got a lot more room where it can get hold of the crystal and start pulling ions off. And so of course it's going to dissolve faster. The smaller the crystals, the quicker the solute's going to dissolve. Make sense, yes? So if you want something to dissolve in a hurry, crush it, heat up the solvent, and stir it. If you want it to go very slowly, don't stir it. Keep the solvent cold and use big crystals of your solute. And there you go. You have taken charge of this tiny, tiny little process and made it go at the speed that you want it to go. Aren't you clever?